How's it going, everybody? Welcome in.
How's it?
I'm here with Dane. We're gonna give you guys a volcanic update. Maybe we'll just give you guys a minute to get on here and also to check that this is working. Yeah, looks like it's
Yep,
going.
looks good.
All right,
Looks good to
so
me. All right.
today we're gonna talk about our volcanoes here in Hawaii Island. We're gonna keep it kind of brief because it's been fairly quiet. We're gonna go through Mauna Loa and Kilauea, starting with Mauna Loa, and we've had two reports come out in the last week or so from USGS Hawaiian Volcano Observatory, which we're showing here on the screen for you guys. So first off with Mauna Loa, Mauna Loa is not erupting. During the past week, there were 37 small earthquakes on volcano summit and upper elevation flanks. They're kind of shallow, not super deep, but within the volcano basically. But basically, nothing has really changed as far as seismicity there. So let's show you guys some of the signals because there's really not much to get out of the text right there, right? So here we have Tilt Mauna Loa Summit. It's
Yep.
kind of still up and down, very little amounts on a daily basis. Not much to see there either. Not much to learn from the past month either. There is some kind of
Right.
changing signals there. What do you think, Dane?
Yeah, the tilt there is still too early, really, for to be used much, in my opinion. We're still kind of waiting until the tilt becomes more useful. But these type of signals I've seen for months, the oscillations and changes, and really hard to tell exactly what's happened via tilt alone.
Right, right. So GPS maybe is a better a long-term indicator. And so here is our cross caldera distance in the past year. And what you can maybe see is that was going up, most of the last year until somewhere right in here, somewhere in a range right in here. It seems like it's a little bit shallower to the right of there than it is to the left of there, right? So you see there's a line going kind of down over here, and then it's a little bit more flat in that upper right part right there. And maybe a little more difficult to see because it's scrunched up here in a 5-year plan. But you can kind of see there's a little dip here that's kind of showing, right? So we've had little ups and downs. Here's a different one that happened last year or a year and a half ago now, right? And some more almost 5 years ago. So do you think we can really say anything about this being a long-term change, Dane, or what do you think?
Kind of too early still yet on that. It's definitely a change. Change. I mean, we've talked many a time that don't like taking the data straight out of the fresh data on the GPSs because when it gets plotted, it kind of looks deceiving,
Mm-hmm.
and then you see it after a few days, and it's like, okay, that's not what we saw originally.
Right,
But this is clear enough at this point that it's like, okay, yeah, that is a at least momentary trend change, right? And it
right,
may not hold, but it could.
right, right. Yeah, we are here on April 10th, and we can see that the line of March is right in there, right? So probably for about a month, it's really not changed a whole lot. And
Right.
that's maybe at first about a month ago we might have seen mentioned some signs of possible change, but really we're waiting, and here it's looking a little bit more significant, but it's still a fairly small time frame in the grand scheme of things, and it could change back, and maybe it's a temporary slowdown, and maybe we don't even speculate on the causes of it apart from saying that it actually is appears to be somewhat more stable, and probably won't last, huh?
Yeah, probably won't last. I mean, expect some kind of change soon up there, but not soon, but some change in a relatively soon time period when you're talking about a volcano,
Right.
uh, geologically speaking. But yeah, this is I mean, you can see on the 5 year, if you look at the 5 year GPS plot across Caldera, just how that has been ramping up on the end of the 2018 eruption until this point.
Right,
Right, and we
exactly,
did have
right there. Yeah.
one little void of data in there, but that was kind of just like a instrumentation issue. Went down
Right.
for a little while, came back up, and it kind of gets back on the same trend as before.
Yeah, yeah. So yeah, maybe one thing we can look at is let's scroll up here and go back to, let's say, the past year of Mauna Loa data, and we can scroll down here. Here's an earthquake shotgun plot, and we can look at the earthquake rates and depths for the past year here. So you've been following us for quite a while, and we've seen the rates have actually peaked quite high, up to 150, 160 almost events in these higher bars right here. But it's really tailed off quite a bit here. If you look at these last few months, since the beginning of the year, right in here, so maybe sometime in February, it's really been tailing off, and we've been having the gaps. It hasn't been consistent high seismicity the whole time. there have been these gaps where it's slowed down, and we've kind of said, okay, we really need to see more of the earthquakes building up and and kind of persisting over time at high levels for us to really be concerned about something more imminent happening in Mauna Loa. And so not only
Right.
have we lost the gaps, like actually the actual peaks of the high counts, or seem to be kind of tailing off. And the same thing, right? We didn't want to say anything too soon, but it seems like it's becoming a little bit of a pattern right here.
And I think the 5-year plot shows this well.
Yeah, so let's
It
scroll
shows the
down.
two
Oh, yep.
running months of
Yeah, so
lower frequency of Earth of seismic.
let's go back up here and click the 5 year and a lot more data.
It looks like you spilled a bunch of M&Ms.
Yeah. So
But
yeah,
yeah, you can see those last two bumps, those last two bars, and the nearest two results
yeah,
2 months that we have. It's relatively low compared to the 4 months prior to that, and some of the trends prior to that. It's not comparable to the lull in activity following the 2018 eruption type of thing, but
right.
it's getting down to the former levels of activity.
Right. So that's a good point. We're not anywhere near back down to the same levels as before the eruption or even during the eruption, right? That's kind of the area
Right,
right in here. But it is kind of coming down from that higher amount from that we've seen in the past year, especially right through here. Right, most of 2019 it was fairly elevated.
right. So maybe they'll give it a little bit more time, see if the GPS starts to, stabilizes before saying anything. Just play it a little on the safe side since it's not really a time sensitive call right now.
Right. Clearly, everyone's worried about other things happening in the world right now, and it's just kind of nice to see.
Right,
Nice to see that there is not as much in an imminent um, activity on Mauna Loa.
right,
So yeah, we're seeing there's less earthquakes. Let's look at our earthquake map here, and this is the last 7 days, all magnitudes, um, and you can see that it's actually fairly light on the earthquakes. Mauna Loa
right,
summits, there's not a whole lot going on up there as far as our threshold on the map here is showing. But we can zoom out a little bit and see that most of our activity is actually down around Pahala, right? Kilauea itself is also pretty quiet. Not only the summit, but the whole south flank is fairly quiet also, actually, right? Fairly few earthquakes considering how many we've seen over the last year. Pahala, a whole bunch of earthquakes. It's hard to really compare how many now to before just visually because there were so many stacked on each other before. You can really
right.
see, right? But definitely,
The one thing that is notable about those Pahala quakes is just they've happened. If you go back through the records, there's at that depth, at that location, there's a history of earthquake activity, but it's not very well understood, and it's not very consistent either. There's no real good correlations with it, the activity on the shallows in both volcanoes.
mm-hmm.
So it's kind of this area that we always treated as you know a odd stepchild that we didn't really understand um, exactly kind of the dynamics there. And yeah, I mean, still a lot is not understood about it. But you want to address some of the findings about that, or some of the recent
Yeah,
publication?
yeah. Well, yeah. HVO did put out an information statement in the last couple of days, right? But before we read that, I mean, it's going to recap a little bit that we think we know because really we don't really know what's going on down there. We've reviewed papers
Mm-hmm.
before in our updates, and we don't have to go into all that much detail before. But in summary, it's believed that that's the some part of the conduit of magma pathway into at least Kilauea. During Volcano Awareness Month, I heard a comment that they believe there's actually two areas of Pahala earthquakes, kind of close by to one another, but that one goes more towards Kilauea and one goes towards more Mauna Loa. So it's hard to really tell that from here, but it may be feeding both volcanoes at the same time, or one more than the other. One thing that we know changed a lot 2018 was the whole south flank moving from the volcano, so that there could be some geometry that's changed down there, the pathway. We don't know. It's hard to really say, but it could be that it's more resonant, or it vibrates more, or it snaps more. We just really don't know, right? But those are some ideas that are kind of floating around there. Um, and the activity in Pahala picked up in 2014, I believe, right? It's been a while. We'll see that in the
Yeah,
report here shortly. But it was more or less similar time to when Mauna Loa was actually ramping up as well. The last kind of
right. And
extended
that's one of
event.
the things we've talked about several times before is how the two volcanoes, Mauna Loa and Kilauea, play off of each other.
Right.
There's good history on the two of one going into a more predominant stage of activity and the other one going into a more relaxed phase, where you can get eruptions at the same time between the two of them.
Mm-hmm.
It's more of a one holds the stick and the other takes a break type of thing. But you don't know when that's happening. Could that be happening now? Maybe, but we don't know yet.
Yeah, well, yeah, it's really too soon to tell, and of course the dynamics of Mauna Loa after a Kilauea summit collapse is kind of a big unknown. We never had that kind of event happen in a modern recording era, right? Modern monitoring era. So that's kind of
Right.
to be determined how that's going to affect it. And we'll talk about South Flank of Kilauea in a little while, but let's look at that HVO report here. And so we are on the HVO homepage, and we're actually under the Kilauea update right here, Kilauea. And even though we just mentioned Pahala may apply to both volcanoes, it's under the Kilauea update. Here's information statement released on Wednesday, 2 days ago. Since August 2019, HVO has recorded over 5,900 earthquakes beneath Kilauea's lower southwest rift zone, as it's technically called, that area.
Right.
About an area about 6 miles wide, occurring 15 to 25 miles beneath the surface. So, not much ground shaking hazard. Most not been felt. Clustering of earthquakes does not mean eruption is imminent. Earthquakes have been recorded in this area for many decades across several eruptive cycles at both Kilauea and Mauna Loa volcanoes. No correlation between activity in this hot zone and activities at the surface has been established, although they're looking into this, right? So
Right.
we've kind of possibly speculated before about, well, maybe if we see some activity there after some delay, we'll see more volcanic activity at the surface, but that doesn't really seem to be the case, what they're saying right here. And of course, the timelines are all up in the air, so we really wouldn't know how to tie those things together, anyways.
Right. We
Um,
just kind of gotta have to wait and see on Paul. It's a complex beast down there, and it's really deep. That's the thing to remember about those quakes is we're talking about 30 to 40 kilometers down.
yeah, very,
This is
very deep.
very deep.
Yeah. So yeah, peak rate of more than 80 per day in February 2020. Right, highest rates ever measured in the area in the 60 years of observation. So I've always measured them for the last 60 years since the instruments have been there, but it's actually reached a peak just a couple months ago, right? So that's very interesting,
Hmm.
and that's why we have to try to think of ideas of why that might be the case, even though we really won't know until we see the consequences, and it might take years to see that. The strongest one of that cluster is a 3.5, January 6. The largest ever was a 4.7 in 2006. Just so people know, like the range of earthquakes there. They're not big earthquakes; they're mostly deep, and it's mostly the clustering of them, the amount of them. That's fascinating, more so than any individual earthquake, right?
Right. And also the tremors that get mixed in there is kind of interesting
Yeah,
too.
that's right. It's not really mentioned in here, right? But a lot of those earthquakes are long period, right? So there's typically a
Right.
more resonant pattern of fluid movement through some narrow conduit, right? Relatively speaking. Um, so yeah, that's very interesting as well. And if it was something more just a breaking of rocks down at that depth, we might say something different, but it doesn't appear to be the case. But really, it's so far down, we really can't directly see what's happening. Can't directly connect it to the surface. It's really difficult to know what's going on there. In any case, we haven't seen any threat from previous events in Pahala like are happening now. So anything to add about Pahala, Dane, before we move on?
Nope, I think that's about it.
All right. So below this Pahala update, the earlier Kilauea update was on Friday last week. And not much here either. Kilauea is not erupting. Low SO2. Minor changes since September 2018. Um, Seismicity is variable. SO2 is low, but um, some amounts going into the pond, and we don't know exactly how much. The pond dimensions are up to 350 feet by 690 feet. And um, we'll talk about, we'll show you guys the depth in a little while as well. So there have been 10 DI events at the summit, similar to January and February. We'll show you guys a snapshot of that as well, continuing low SO2. The pond was last sampled by drone in January, and they're planning more sampling. We haven't seen any results of that, but
Right, that's what I was just thinking.
I imagine if there was something shockingly different, we would have heard something, right?
Probably.
Unless it was so shocking that there was no explanation and some kind of further research. So we'll have to wait and see. There's no information we know about that so far. And given that everyone is working from home now, it may be a little while still. Um,
Right. So maybe you could answer this question before we get down to Kilauea. What is you worked at HVO and you kind of know kind of the instrumentation that's going on. What is the capability for them to work remote?
it really depends on how much of the regulations are who everything applies to, right? Because in some sense, you could consider some of the HVO work to be critical essential work, right? Maybe more so if the eruption was happening right now. Um, most I mean, there are a lot of people that actually can work from home. Most of the researchers can work from home because there's a lot of data manipulation. You spend a lot of time in the office, more so than you'd like. Typically, field sampling or field research is somewhat periodic, or sometimes even seasonal, depending on who's coming to collaborate. That kind of thing is probably all shut down, apart from possibly maintaining equipment that might need maintenance. Let's say you have an issue with data relay in the next month. You might have to send someone out to fix that just because you'd like to have the data coming in so people can keep working from home and not
Right.
worry about eruptions happening, right? So it probably goes both ways, right? So I mean, but there's definitely HVO definitely has two um, different kinds of workers, right? You have your research scientists who are doing a lot of the analysis and everything else, and you do have a lot of
Mm.
technicians that are installing and maintaining equipment and all that kind of stuff. And so it might be different. The researchers might do better from home, whereas the technicians might need to have more time in a shop to maintain, build electronics, or deploy them, maintain them, repair them. Because even
Right.
if nothing's failing right now, there's a whole repair schedule that they follow to try to keep things relatively up to date, right, with the whole network. And some of the equipment has been installed in the ground for 20 or 30 years, right? So you'd like to go back and upgrade it, improve it, check the connections, or what have you, right? So,
Hey, Jonathan. See you in chat.
right on.
Oh, and Dick's in there too. All right, guys.
All right.
So yeah, let's
Yeah, welcome,
get on
guys.
to Kilauea.
All right. So, okay. That's maybe all we can really say here. There's not a whole lot. It does say that there's areas of persistent elevated ground temperatures and minor gases still in the vicinity of 2018 lower East Rift fissures. So that's not going to change. There's nothing new there. It's all kind of the same. So let's move on to the Kilauea signals. So we are here at the HVO homepage. Kilauea Deformation, tilt and GPS. Today tilt's not telling us much. It's really too short a time, and the changes happening there are more long term. Let's just zoom all the way down to the 1 month right here. And we can see deflation, inflation, deflation, inflation. This was a little earthquake that happened with a little offset, so the baseline jumped from a level that
Hmm.
was more like down here to up here, right? But apart from that offset, it's really the same pattern, up and down, up and down, up and down. Almost regular here, right? So we're not expecting much change. At least I'm not from this pattern to the summit. Although it's really
Right.
kind of, still conjecture at
It's
this
held,
point, right?
it's held for like 6 months or something. The uptick in frequency of the DI's been pretty consistent.
Right, right.
Just DI after
Yeah,
DI after DI.
we
As
did,
soon as it gets out of one, it goes into another with a little delay.
right. I think the last 2 months have been pretty DI rich as well. We might have had 1 month towards the end of last year that was kind of slow,
Right.
but then that was kind of an abnormality, really, right?
Right.
So, um, magma is down there somewhere still. It's still cycling in a way, probably related to gas pistoning at some deep chamber somehow. That's maybe producing a signal, but it doesn't seem to be moving anything at the surface really that we can tell. Right. GPS at the summit. This is a cross caldera length, right? So you can see is that for most of the last year, it's been spreading apart. Basically, the north rim of Kilauea is moving away from the south rim of Kilauea, and it's been a fairly steady pattern. You can kind of see. I'll try to draw a straight line here. Whoop, that's not a straight line. Draw a straightish line, kind of there, and then this last section is a little bit kind of flattish, and then kind of almost flatter up here again. But it's a little messy. But you can kind of see that, especially this last, perhaps 2 weeks. Not a whole lot of change. Definitely the change in the last month is a lot less than it was the month before that. A year ago, something like that, right? So it does seem like the maybe
Mhm.
the maybe the spreading is continuing, but the spreading we've mentioned before could be for two reasons. There's a combination of magma coming in, pushing from below, maybe actually swelling those edges apart, but there could
Yeah,
also be the south flank pulling
that'd be
more
kind of the
magma.
traditional uh, explanation of those meters, right? If you
Yeah,
see it going up, the traditional explanation would be it's magma causing inflation,
right.
right? So the secondary explanation is still out there, right? You want to kind of think of that a little more on that one,
Yeah, I mean, we've mentioned that because the South Flank was moving so much, ever since the 6.9 earthquake in 2018, that the South Flank actually connects all the way to the southern part of Kilauea caldera, and so there could possibly be an effect. We've speculated, the South Flank all the way in the south wall of the caldera, and maybe some of the movement is being contributed from some of the South Flank movement, added to any magma movement. It's hard to separate those two things really.
right?
Um, but both are possibilities, right? We do see a clearer signal closer to the East Rift Zone because there are a lot less faults and there's a lot less complexity in the geology between the Rift Zone and the actual coastline than there is between a summit and that southern south flank area. So it's
Right.
not so straightforward just because of that. But this kind of slowdown, a little bit of a slowdown. We did hear actually even back in the January Volcano Awareness Month how they saw the INSAR was showing slowdown, right? So really you could say that we could draw a line. Whoops, that's the wrong button. Whoop, nope, that was the wrong button too. Sorry guys. Okay, that back from somewhere in here that the rate's been lower than it was before that,
Right. You can kind of see that.
right? So they actually mentioned a change in INSAR back in late January. So that could be as far back as it goes, and so that kind of pattern. We're not going to show you INSAR, but just kind of mention that result, and a little easier to see here in this five-year plot. A little bit of a wiggle here at the end.
Right. And you can see at that 1 year plot, just that little bit at the very end too. It's coming more so almost. It's
Yes.
interesting. It's like almost flattening out up there.
It's almost like it went up and then it came down again a little bit, right? I mean, very very minor
Right.
amounts. Like within this is maybe within a noise even. It's hard to even say anything conclusive about that.
Like, yeah, but it could just go back on the same trend too. I
Yeah, it could
mean, it
easily.
could
Yeah,
just
you can see just back in the beginning of March, it kind of went down and looped up, and before that as well. It's more the long term pattern I'm interested in rather than like this little change in the last week or so, right?
yep.
So okay, in any case, it's still fairly quiet. That there's no sign of gases coming out there, as the report said, and no report from the. So this is our East Rift Zone right here, and we can see that it's maybe flatter. It's really hard to say convincingly, but it looks fairly flat at least from March, right? Maybe a slight rise right in there, and a slightly larger rise
Yeah.
earlier in the year,
And
right?
again, we've talked about the station that being across the Pu'uo'o cone, across the
Right,
rift down to the Kuzi, and that's you know, it measures ground movement in an area where the ground has moved. Um,
right, right.
it's hard to say exactly what it means.
Yeah, and
And we've seen
go ahead.
like many times where it creates like a wiggle or something like that. It's like, it looks like this one's doing something. Up, never mind. It's gonna do something. Up, never mind. Like
Yeah, yeah. Can be a lot of noise in there. Yeah, for sure. Yeah,
a lot of noise.
yeah. But just to kind of point out that the pattern isn't that much different on the East Rift Zone, and we see it at the summit of Kilauea as well.
Right.
And so, okay, if we actually, let me switch my tabs here and show you guys that if you go to the past year page on Kilauea, so here at Kilauea monitoring past year, and there's our Kilauea earthquakes, right? So our kind of background level that's been high ever since the kind of our 6.9 aftershock creep sequence. Yeah, it's more or less
Yeah.
steady, maybe a little bit of, yeah, it's kind of hard to say anything different right there, really.
Right.
But scrolling down, there's a new part of the website, right? We're going to go past the GPS for the year. The gas data we pointed out to you guys a little while ago. They actually are plotting gas as measured at the summit. And, all these are fairly low, 35
Yep.
tons a day, 40 tons a day. Nothing as
Incredibly
recently.
low.
But yeah,
Yep.
still, at the highest one, 70 tons a day, and doesn't really compare to the 200 or so we had before, even in non-eruption times before the Summit
And
Lava
we've
Lake
talked
opened
about
up.
it. Yeah,
Yeah,
we've talked about that Summit Lava Lake, or not the Summit Lava Lake, the new Summit Water Lake, and it might be doing some SO2 scrubbing out of that,
exactly,
like,
exactly.
absorbing it into the water. So we're kind of getting a dulled down sense of the SO2,
Yeah. So
but
really curious to see more of that.
it's
That,
hard to
that's
know.
really where the drone samples come in, right? Like by having the
Right.
chemistry of the water, we can maybe could tell more about the gases.
Yeah, you
But
could tell. Yeah, tell how much it's changed since the last time it was sampled
yeah,
in terms of absorption.
we'll just have to wait on
But
that.
yeah,
And then down here a little further on this page, now there's a summit water depth chart, right? So going back to when it actually emerged, which was late July, early August, right? So and then it's been fairly steadily rising. You guys can see there's not been any real, well, a couple of little wiggles, but really, maybe with an error of the measurement technique from using a laser rangefinder and other visual measurements from how far is it, like a mile and a half or something.
Right, yeah, it's 1,800 feet at least, I think.
1,800
It's
feet,
pretty,
so half
yeah,
mile.
it's straight down, yeah. Yeah, but still there, that's a long, long, long ways
Yeah,
down there.
so
But it's come up, it's about 100 feet now. It's about 100 feet
yeah,
depth in that water lake.
yeah, that's right. Yeah,
So,
so yeah, 33 meters, 34 meters right in here, right? It's about 100 feet. Yeah. So yeah, you guys can track this here as well on the HBO page. So we can move on, and I'm gonna switch over here to the Hawaii tracker page because we have laid out our 2-year GPS plots by station. And what I have laid up here, I'm not gonna go through everything, just the couple stations we've been looking at the south flank of Kilauea. And so this station, just to remind you, Kalapana Trail, it's south of the East Rift Zone, kind of not that far from the bend actually, right? So and east signal is not as interesting to me. The one that really shows south like movement is this north signal, right? And if the line was going up, it would be going north, and if it's going down, it's going south. So what you're seeing here is essentially a southern pattern moving to the south, right? Ever since the eruption, and we've kind of scrolled off here, but before that, we actually showed you guys before that there was a line that kind of went this direction before. And it was a little shallower. This one over here on the right is actually close to 4 times steeper than
right,
existed before, right? So the south flank was moving perhaps that much faster, at least at this one location. It's not the same everywhere, it's highly variable. But what I'm going to point out is that more or less in that same time period, right in here, right? Remember, this is a 2-year plot now, so it's slightly closer to the right. Um, we do see a little bit of a flattening as well, right? It's still going down. The south flank is still moving to the south, but it doesn't look like it's moving quite as fast as it was before, right? So that's curious to
right.
see that at the same time as we see the summit patterns and the rift zone pattern. And let's scroll up
Yeah,
here
the
to
PG2R as a,
PG2R, yeah, which is not
yeah,
actually
that's a,
PGV.
no,
More on the
no,
label.
it says that, it said that for a long time, but it keeps, yeah,
Yeah, it's not what it is. It's actually also a south flank station, a little bit to the west of Kalapana Trail, and was showing south flank um, movement as well. There it is going down, and maybe here at the end, somewhere in there you can see it's a little flatter as well, right? So south flank seems to be slowing down finally, right? This is something we kind of speculated at that could happen right after the eruption ended, right? We looked at the historical records. It's not very detailed going back, but we saw that, for example, there were 3 magnitude 5 earthquakes more or less after
yeah. I think they
the
were up to six. We're talking about them being up to six during that time, three of
right.
them, and one happened pretty much similar time period as when we had that 5.3 after the eruption, or 5.2 after the
Mm-hmm.
eruption, South Flank. So that was one interesting thing to see. And yeah, we have talked about this many a time. This type of expectation almost that it will slow eventually. We just don't know when
Right,
and what that slowing process will look like either.
right. And what the final speed might be as well, because it could slow, then
Right.
slow a little bit more, then slow a little bit more, and then finally eventually gets to that kind of equilibrium speed, right? So we may not be there yet, but it does. We are seeing some kind of change that is consistent with that at least. Anything else to add about the South Flank, Dane?
No, I think that covers it. It's still the driving this boat that is Kilauea.
Yeah, yeah. For now, at the very least, that seems to be the case. Yeah. So
Right.
one last novelty to share with you guys, and that is an article in Nature that came out a couple weeks ago almost, and this is basically
Mm.
talking about coronavirus impacts on measurements of the Earth. And so in this case, we're looking at seismic noise. This is an article that's focused on scroll right down to the graph here in Belgium, right? And so basically, as human activity, that may be cars and trucks, or in some cases, people actually walking by the station. Although you hope they chose a better location for the station than that. Um, actually will be detectable as background noise on these signals, right? And so this pattern right here is showing February through March of 2020, right? As and coronavirus lockdown begins here, right on this graph on March 18th. And so just so you guys understand what's going on here, these little darker lines, if you can see them, these are the weekends, right? And they correspond to little dips in activity because people aren't driving around as much, at least in Belgium, right? And so what we're looking at is really the baseline up here before lockdown, and then after lockdown, some transition period. You actually can see there's a lot less noise from cars driving around, and so that's just an interesting curiosity that Dane found.
Right, and that's a really early date, plot too, considering when the lockdowns were actually being taken in across Europe, March 18th. That's kind of on the, it was. early lockdown, but it was, there's different degrees of lockdown, right? It's all kind of goes under the same word, but they mean different things. I'd like to see what it looks like over the past like week and a half, 2 weeks,
Right.
right? I bet it's substantially less because I've seen the data from Google on the European countries, and it's a huge drop off.
Yeah, definitely.
But yeah,
Yeah.
that's
Yeah, I remember
it's very
when
interesting.
when I was in grad school in Ann Arbor in Michigan. We had a seismometer there, and mostly it picked up construction at the on campus, right? Because there's always construction renovation happening on campus, and so that's all we really see in a seismometer. And I imagine likewise there's other stations and urban areas that are probably seeing similar drop downs. And so if there's any board seismologists out there, you can go look for this data at your own home turf,
Right.
and let us know. I'll be curious to see what's up with that.
As long as you had a baseline before, you should be good.
Oh, that's right. Yeah. So yeah, that's all we got for you guys today. In summary, the volcanoes are quiet. Maybe slightly slowing down a little bit. Some slightly slower equilibrium. It's probably not going to last. We'll keep an eye on it for you guys. Nothing to worry about now,
Yep.
which is really great because we're all busy, stuck at home.
Ain't nobody needs that volcano to erupt right now.
Yeah, exactly. So let's see if I can, if I have any questions, I can maybe address one or two real quick. But otherwise, looks like we don't have any questions that I can see. So thank you guys for joining, and we
What
ho until
about
next time.
the? Okay, I think we did actually address that. Yep, sounds good. All right, man.
Okay, Dane. Thanks,
Till
Dane.
next time.
Thanks, everybody.
Thank you. All right, take care.
Aloha.
Aloha. All right, off there. Yeah, that went all right.
Yeah, that was great, considering it was my first OBS stream, I thought.
Yeah, it's not too bad. It just takes some getting used to.
Yeah, well, I've seen you do it enough times to get practice, right? But
Right, right. I had to learn it the hard way of just like, nope, that doesn't work. That fails. Okay, that breaks things. Let's try this.